Lines are straight, but yeah, they have different angles or steepness or slant. Well, a measure that measures the steepness and the slant of a line is called the slope. Measure steepness and slant. Because yeah, some lines are steeper than others, and they have different slants also. And so yeah, that's what slope measures, okay? So there's several ways you can think about slope. The way it's chosen to be is the way you find the slope is you take the change in the y, change in the y's over the change in the x's. Here's what I mean by that. Let me put one up here and demonstrate it. Okay, so here, let's say I've got a line that's got 1, 2 point, and then 1, 2, 3, 4, and 6. 1, 2, and 4, 6. That's my points chosen here. Well, if we look at it there, yeah, so the change in the y's, so if you look at it, the y's have changed from 6 to 2, from 2 up to 6, so we've changed the y there 4, and then we changed the x's, so the x's have gone from 1 to 4, so those have changed by 3. Okay, so that slope is 4/3. Positive would be 4/3. Now, in practice, it's probably better to have a little formula. And the one thing I meant to mention a while ago, but the letter designation for slope, if you don't already know, is the letter M. M is the letter for slope. But yeah, there is a formula here that we use to represent this. If you think about it, what we did to get the top number here, the 4, notice I had 6 and 2, so I subtracted those, right? So I took the second y and I subtract the first y. So formula-wise, that's usually how we remember it. Second y, or y2 minus y1, first y. And then the change in x's, very similar, because yeah, here I had the x is changed by 3, so I took another way to think of it is I take the second x and subtract the first x. And so this little equation here, that's what we refer to as a slope formula. But really all it is change difference of the y's over difference of the x's, another way you'll hear it. You don't already know that. Okay, so we'll apply this formula to a couple of examples here in just a second. But the other thing that I wanted to refer to, another way, so slope is all this. Another way we can refer to slope, however, is also by another little phrase, call it the rise over the run. Rise over run. And here's what that means. On my example here, so the rise and the run refers to this, and you can do it on either side, doesn't matter. But so let's say I make a little kind of little triangle here. Look at that. When I refer to the rise, that's this right here. So it's rise is how much it goes up, and then the run is how much it goes sideways, right and left. But you see that refer to the rise of the run because the rise deals with the x's, the y's, and the run deals with the x's. So another way to refer to it, and that can be helpful in certain instances too that we'll speak about in just a second. Okay. All right, so let's use the slope formula on a couple of others here. So find the slope of the line through the points. Follow. Number 1, 5, 2, and 1, 6. Yeah, I mean, there's different ways, but if we use that formula here, just to kind of do a couple examples of it. So we take y2 minus y1 over x2 minus x1. All that means, like I said, is you take the second y, which in this case is 6, minus the first y, which is the 2. And then you, x2 is second x, so that's 1, minus first x, which is 5. And so that's 4 over negative 4. Right? Now, it is a fraction, so it can be reduced just like fractions can. 4 divided by negative 4 is negative 1. So this slope can be simplified. It has a slope of negative 1. I'll just do one more here because the tricky ones, of course, are the ones that are involves negatives. Sometimes it's a little tricky. All right, so same thing, slope through the line with points 3, negative 2, and negative 7, negative 4. So the slope there, again, it's y2, which is negative 4, minus y1. So we have the double negative there, don't we? This minus is from the formula, and then the negative 2 is from the y1. Then we take x2, negative 7, minus x1, 3. So as we know, when we have that double negative, yeah, those turn into positive, so we have negative 4 plus 2, which is negative 2. And then negative 7 minus 3, we don't have the change there, it's just negative 7 minus 3, which is negative 10. So negative 2 over negative 10, but that, of course, can be simplified. 2 negatives, again, negative divided by negative is positive. I don't necessarily write the positive, but just make a note there. And then, of course, 2 and 10, we can reduce those by 2, so it's 1/5. Positive 1/5. Or just 1/5. Okay? All right. Now, the other thing while I got these up here, so we had one slope is a negative, the other slope is positive 1/5. Well, if you look at the graphs here, these 5, 2, real quick, it's here, and then 1, comma 6, so 1, 6 would be up here, right? So that slope is negative 1. This one, 3, negative 2, is here, and then negative 7, negative 4. Here. Okay? And we can do this with the others too, but what I was going to point out here, so this one has the negative slope, and this one has the positive slope. And of course, we note there, the difference between the two, the negative slope, from left to right anyway, the direction is downhill, right? And that's not just for this one, for any for any line that has a negative slope, it's downhill. This positive slope, from left to right, we're talking about, it goes uphill, and that's always the case for positive slopes. They go uphill from left to right. And one other slight little point here, I maybe didn't mark them off exactly the same, but do you notice here, you know, this one, forget the negative, it's absolute value or whatever is 1. As far as steepness goes, this one is less steep than this one, isn't it? This one has a little more steepness to it, and this one's more gradual. And you compare the 1 and the 1/5, yeah, it tells about steepness. The larger the number there is, the steeper it is. So just a small little point, but yeah, positive and negative slopes, I want to note that. One other one they have, kind of the question, this leads us to our last thing that we're going to talk about today anyway. What is the slope of the roof? And I'll try to draw my rendition of my, that's the corner of the house anyway, or half the house. So it peeks out right there. I have one of those here. So this is the roof, half of it anyway. But here's what we've got. 25 feet, and then to the peak is 7 feet. Yeah, so this is one place you might see slope. It's referred to as pitch, but pitch is just a slope. Yeah, but how would we compute it? Well, it goes back to, instead of using the slope formula here, we refer to the other form, I guess, which is the same, but slope is rise to run, or rise over run. So it's how much it rises from one point to the other point, and how much it runs. So what we're talking about is from this point on the edge to that point at the peak. So what's the rise to get to that point? Well, the rise is here, isn't it? It's the 7 feet. And then the run is from this point to this point. This here is the run. How much it rises to how much it runs. So that's how we calculate that in that case. And we'll use that also for the next example. But is that okay with everybody? Just do the rise to the run. Okay. All right, so last but not least here, let's do one more. All right, we're going to graph some more lines. But here, we're going to do it not from points or, well, from a table or anything like that, or intercept. We're going to do this. All right, so graph the lines with, number one, slope 2/3 through the point -5. Well, we still need 2 points. We've got 1 point, and we've got a slope. So how can we utilize that? Well, here's how we do it. One way to do it. All right, so yeah, we've got 1 point, so we definitely go to -5, x, 4, y. So it's up here. All right. Well, the way we can use the slope on that is the slope tells me the rise over the run. So that would mean I'm rising 2 and I'm running 3. So if you do them in that order. So I rise 2 from my point here. So I go up 2, and then I run 3. So sideways 3. Gives me another point. Rise 2, run 3. Easy way to do it. There's your line. Number 2. How about slope -3/5 through -4, -2? Well, -4, -2 is down here, okay? But now my slope is -3/5. Well, one way to interpret it is, just like I have there, the rise here, -3, over the run, so the run is 5. So a rise of -3 would of course mean, or actually falling 3, but so the rise of -3, we go down 3 here. And then run 5. Now, which way? That's still +5. The top is negative, but the bottom is positive. So it's still to the right, yeah. So 1, 2, 3, 4, 5. So you still go, even though it's negative for the top, you still go +5. So, yeah, there's confirmation again. The slope's negative, so it's downhill. Is that all right? One more. Number 3. M equals 5, and we're going through 0, 1. M equals 5 through 0, 1. All right, so 0, 1, go to that first. 0, 1's right on the y-axis. Now what? Well, M means the slope. So the slope, I do have the slope again. The slope is 5. And I'm going to interpret that as rise over run, but I just have 5. That's what I do there. Well, I need to make it sort of into a fraction, right? If I write 5 as a fraction, one way to do it would be 5 over just 1. And so my rise is 5. My run is 1. Rise 5, run 1. You got it. Rise 5, run just 1. So it's a pretty steep one. All right. Is that okay? Any question or concern?